Good afternoon, and welcome to another Webinar Wednesday with XenTegra. We're going to give everybody just a couple of minutes to get in the room, and we will kick off. Hope everyone's having a good afternoon or morning, depending on where you're located. Look forward to sharing some great tidbits today with KnowBe4 and our guest, Roger Grimes. Give everybody just a couple of minutes to get in the room.
Anybody know what that picture is behind me? It is the Alan Turing computing bombs, BOMBES, the first computer machinery that he and his team developed in World War II to decode the German Enigma code cipher. Prior to the Allies breaking that cipher, the Allies never won a battle, and they never lost a battle after he created those, saving millions of lives and ending the war 1 to 2 years earlier than otherwise.
That's cool. I don't know that I've ever actually seen a picture of it before, Roger.
Yeah, I actually called the museum there over in the UK and said, hey, I had seen a picture in a magazine saying, hey, can I get that picture? And, oh, it's really not in our museum. I said, can I pay y'all to get somebody to go to the other museum? And if you do, I'll give you a big donation. And they said, yes. So I gave them a big donation. They had someone go take a picture, send it to me, and I blew it up to 6x8.
That's amazing. Well, I'm going to officially hand over my geek card to you, and I'll put on my host hat now, and we'll go ahead and kick off today's webinar. So thank you everybody for joining us. My name is Phil Sellers. I'm a solutions architect here at XenTegra. I want to say welcome, and I want to say welcome to my guest today, Roger Grimes from KnowBe4. Before we get started and before I turn it all over to Roger, let's just talk a little bit about work without boundaries. Once again, XenTegra is giving away a Ford Bronco. Actually, I hear it might be 2 this year. But how can you get in on this great giveaway? Well, if you will go to workhasnoboundaries.com, you can get all of the information about what it takes to qualify and how you can get entered into this giveaway. Good friend of mine, former colleague, actually was drawn last year for this prize. So it's a real deal. I've seen it with my own eyes. Thank you for joining today's webinar. After the webinar, we are going to have a drawing for a Amazon gift card, a $100 Amazon gift card. So keep a watch over your email boxes, and you will get notified if you're the lucky recipient of that prize. So as I said, my name is Phil Sellers. I'm a solutions architect here at XenTegra. You're finding me on lucky day number 8 employed with XenTegra. Prior to this gig, I have always worked as a customer, helping run IT teams, helping solve problems, just like you're doing for your organizations today. Been in the industry for about 25 years. Underneath all this hair dye, it's actually pretty gray. So I've got the gray beard to show for it. I like to say I'm a software-defined problem solver. I focus in data center and cloud technologies here at XenTegra, and so we're here to help you. For those of you who haven't heard of XenTegra, who are we? We're a reseller first. We work with about 80 different vendors today. We're a nationwide reseller. We're also a service provider. We provide managed services as well as consulting services to you to help you get the most out of your technology. We're also a solutions provider. We work really hard to try and help you create strategies and create solutions that will help you solve your problems. XenTegra is about a 10-year-old company. We've focused in the end user compute and VDI space for a long time. but we're much more than that too. We have coverage across all sorts of different software providers. You see a few of the logos here on the screen: Citrix, VMware, Microsoft, Nutanix, and of course, our guest today, KnowBe4. One of the key differentiators, I think, for this organization is that we believe in helping enable our customers through education, events like today's webinar, and all sorts of other ways that we give back, including subsidized conference passes. And if you haven't heard about our 90% off conference pass program, then you should talk to your sales rep about that and see how you might be able to benefit from some additional education as well. So without further ado, I'd like to turn it over to today's guest. Roger, how you doing today?
I'm doing great. Thanks, Phil, and thanks everybody else for showing up. Let me go ahead and share my slides, so stand by. Here we go. Here we go. Coming up there. So this is called How and Why Hackers Hack and Your Best Practice Defenses. Really, what I hope to give is everybody a really quick overview of what the hacking world is like today, and malware and hackers and that sort of stuff. And then at the end, the 4 or 5 best things that you can do to protect yourself and your organization. If you haven't met me, Roger Grimes, been doing computer security for 34 years, have just as much gray hair or more than Phil has. And I've written 13 books and over 1,200 magazine articles. Here's some of my books. I'm going to share a lot of the lessons from those books so that you don't even have to buy them. Now, I am going to give you the best lessons out of them that I can give you. And I do work for KnowBe4, the world's largest integrated security awareness training and simulated phishing platform vendor, which is a lot of words to say. We try to help people not to be phished and socially engineered. And that's a big deal because most hacking and malware is related to social engineering and phishing. And I'll talk more about that later. And again, we're just going to talk about how hackers hack and then your best practice defense is really probably one of the most common questions I get. And by the way, I speak really fast all the time. And I've got about 45 minutes, I think, to go through, what is it, 54 slides, something like that. But I speak fast all the time, even if I only had 3 slides. But one of the most common questions I get is, why did the hackers hack me personally or my business? Well, most of the time, it's just because you're a victim of opportunity. It was a random attack. The hacker gangs, and there's thousands of them around the world, are sending out literally tens of millions of phishing emails. They compromise, millions of devices. There's hundreds of million malware programs, and it just happened to be that day that you or a coworker or somebody clicked on the wrong link. That is why most people end up hacked. But it also could be because you or your organization was specifically targeted by a human adversary. That used to be really rare. It's a lot more common today. It's not as common as the victim opportunity attacks. The victim opportunity attacks are literally hundreds of millions to billions a day. The targeted adversary ones are maybe 1 million a year or something like that. The good thing is regardless of how you got attacked, or why, the same 4 or 5 defenses I'm going to tell you will work against them. The next question is like, why are they attacking me? There's no official statistics on this. I'm just using this as a guess, but I think most people would agree with me that the vast majority of hacking happens because they're trying to steal money. Why are people robbing banks? Because they're trying to, get money. And there's many other ways that, there's many ways they could take that money. They could steal it directly from you. They could rob your bank account, your stock account. They could steal your identity. They could steal your credit card information. They could do ransomware, whatever it happens to be. That's why most hacking happens. They're trying to steal money, but it's not the only way. We are seeing a lot of nation state attackers. Every sufficiently capable nation has professional hackers they hire to attack their adversaries. What's different these days is that the most common target of a nation state attacker is a regular company. It used to be that the average target of a nation state attacker would be a government target, a military supplier, or something like that. These days, many nation states, Russia is responsible for most of the ransomware. and makes money off of it. Iran, North Korea, they're stealing money and cryptocurrency and bank accounts and that sort of stuff. China's stealing intellectual property. There's just a ton of nation state attacks going on today. And the most common victim is just some regular company that really had nothing, to do with the military or the government. I always tell people, like, American hackers, the NSA has got tens of thousands of hackers, but they're not planting ransomware on some organization's computers and saying, pay us $1 million or we're not going to release your data. There's a lot of corporate spying going on still, that we see, and that's usually when one competitor is trying to learn information about another competitor. Or it could be that an ex-employee left one company, went to another company, but the login information is still valid, so they come in and take a look at that old company's information or still their customer list or whatever. We do see a lot of trusted insider attacks where somebody that's currently working for you, usually they're people that were really emotionally in love with your company, and then somehow they felt wronged, and so they want to get revenge and they start doing bad things. Or even can be that they're just stealing money from your customers. Once, many years ago, when I was a VP of IT, there was an employee that I really liked, and she was a help desk employee. And I said, what do you want to be? She goes, I want to be a database administrator. So I sent her to database administrator classes. And over 2 years, I tripled her salary. And I really, really liked her. At the end of the 2 years, we found out she was actually stealing credit cards from our customers and buying Dell laptops. Unfortunately, she was getting them shipped to her house, so that didn't work out for her. And I haven't talked to her since she was arrested, but I'd love to ask her, I had tripled your salary. Why did you feel that you had to steal from our customers? But, that's just the way some people are. Gamers are a special type of hacker. It's kind of weird what they do, and some of the stuff can have serious consequences. But most of the time, if a gamer becomes a hacker, they're trying to, attack some adversary gamer. They're in some, shoot 'em up game, and they want to slow down their adversary. So they'll do denial of service attacks against a gaming server to make the competitor slow down, and then they shoot and kill them. But there's also like a huge bunch of malware. If it breaks into your computer, we'll look to see if you have particular games installed. And if so, they may steal your gaming credits. When you're gaming, you can earn levels or pay for levels or equipment or food or supplies. And if the malware gets in there, sometimes it will steal those gaming credits or supplies, and then the bad guys resell it for pennies on the dollar. They also are known for doing swatting attacks. There's literally, it's befuddling to me, but over 100 of these are done every day on average. But that's where they'll get mad at somebody that they're gaming against, and they'll pretend, they'll call that person, they'll find out where that person lives, call their local police department and claim to be a mass killer, or that they're hiding in the closet and the guy's trying to kill them. And it gets the law enforcement and the SWAT teams to come out and harass that person. At least twice it's ended up killing people, both times innocent people. One time, and both times the SWAT team showed up at the wrong house because the swatter hacker had given them had gotten old addresses off the internet. In one case, the SWAT team showed up and said, hey, get down on the ground, and the guy just had a heart attack and died. Completely innocent dude. The second time, the SWAT team just shot a guy. He was like opening his front door to see what all the noise was. It was a SWAT team, and shot and killed him. But in both cases, the teenage swatters got located, found, arrested, put in jail for second-degree murder. So that's kind of a weird thing. Sometimes they'll break into your computers just to steal your resources. A lot of people don't know this, but there are literally tens of millions of compromised devices and laptops and computers and cable modems and web cameras and routers, Wi-Fi routers and stuff that are compromised by malware bots that turn your devices into bots that will either manage some type of malware network, ransomware network, or they'll use your computers or devices as bots to do denial of service attacks against other people's computers. Or maybe they're mining Bitcoin. Mining Bitcoin, you got to do trillions of transactions a second to try to earn a Bitcoin. That's expensive, takes computers and electricity and stuff like that. And so they'll just install a Bitcoin miner Trojan on your computer and use your computer's processing power and cost to mine the Bitcoin. So there's a lot of people that think, oh, my computer's so slow, I hate Windows, or I hate Comcast because my network's so slow. And what they don't really realize is that they're part of this massive botnet that's slowing them down if they scan and clean their computers or devices or whatever. You can also be hacked because someone decided they didn't like your company's actions for some reason. They don't like that you did something, and so they decide they're going to hack you to try to cause financial harm or embarrassment. Their hacktivists are really famous for doing doxing, which means they find confidential documents or information that they share with the public, usually in an attempt to embarrass the organization, maybe some embarrassing emails or something like that. Or it could be like they'll put out the home addresses of the CEO or the email addresses of the CEO's wife and kids and stuff like that. So, they're just trying to harass people, cause some type of interference or damage. If you're lucky, maybe it's only adware that you got hit by. Adware is usually it modifies your computer or your browser in such a way that when you're online, either unbeknownst to you, your computer is visiting different websites that the adware gets paid to go to create connections to, or you're in your browser and you're like, oh, I want to search on, the latest election results, and you end up at a website selling Viagra, or something like that. That's, adware. A lot of people call it pestware. And they'll say, hey, if you get hit by adware, it's not that big of a deal because it's not a password stealing Trojan. It's not ransomware. Hey, be lucky you get hit by adware. But I try to tell people, however that adware got on your computer, your network, is indicative of a hole in your defenses. You either got socially engineered, or you're unpatched, or at a misconfiguration, or someone knows your password. But anytime you see adware, just remember that's canary in the coal mine. There's something wrong with your defenses, and you should figure it out so that the next time it's not ransomware or a bank stealing Trojan or something like that. When I first got into fighting hackers in 1987, almost all the hackers were teenage boys, just trying to show that they could hack people and write computer viruses and stuff like that. We called them script kiddies and things like that. That was almost all the community. But that started to change about 20 years ago, and about 10 years ago, it changed in a big way. And this is a big thing that a lot of people don't know. Almost all hacking is done by professional organizations, gangs, and even corporations. There are literally thousands of organizations around the world that what they do for a day job is hack other people. They're typically in different countries so that they can't be arrested. Like 82% of the ransomware comes from Russia. And there's a lot of places in Russia where it's the day job of people. But a lot of them, they're even like companies that are traded on their country's stock exchange, and they claim to be marketing, an internet marketing company or something. But really what they do is hack people for a living. Or in India or Sri Lanka, there's thousands of people that will call you as their day job, say, hey, we're from Microsoft and we detected a virus on your system. These are people that are hired, usually through, many times over typical resume sites like Indeed or Monster.com. They have, they got to apply for vacation. They show up 9 to 5. They have bosses and stuff like that. They have every hassle a regular job has, except for their job is hacking into other people. So it is to say that most hacking today is not some fat kid in his basement, his mother's basement, drinking Mountain Dew. It is a professional organization that is many times making millions, if not hundreds of millions, if not billions of dollars from attacking other people. And this really came home to me when I saw this diagram. This is a diagram of a good company called CyberWise, saw the source code of a really popular banking Trojan called Cerebus. It was a really popular password stealing Trojan that was then steal money from your bank account. And they got the source code and they put together the infrastructure that was behind this malware program. And if you look at it, it has a lot of dual redundancy in it. It has redundancy and then dual redundancy. So it has lots of redundancy built into it. They have admin consoles, they have customer servers, they have license key servers and main data centers, and they're made for PCs and for cell phones. And all I know is when I saw this, it made me realize this really is a professional thing, because this is the infrastructure that any professional organization would put behind their application that they put on your phone. When I was at Microsoft, we would have meetings for months to plan what is the infrastructure we need to support this new feature, this new application. Well, the malware writer is doing the same, and that's really hit me that they really they think that they're legitimate companies. They're literally hiring people that could work and do these sort of things. The person that created this infrastructure here could work creating infrastructure for any real company. It's just that they decided that they wanted to work for an illegal company and I guess make more money, at least for a certain period of time. And that's the thing to realize, that what's going against you today is very professional, very organized. Usually how they got into you is either automated malware. Usually someone's tricked into running a Trojan horse program, but it could be a computer worm or virus or something like that. or it could be because you were targeted by a human adversary hacker. Really how it occurs most of the time today is this hybrid model where the initial access into your device, your network, was this malware program, and then it dials home. You can tell I'm old with a gray hair because I say the word dials. For people who don't understand the word dials, it used to be that we had phones that you had to get dialed tone. Now, so it connects over the internet to its command and control servers, tells the hackers they've broken in, and then the hackers take over. And that's really what happens today. This is how most hacking happens today, is that you have this victim that's connected to the internet. They don't have to be connected to the internet to be hacked, but most are. Most get tricked into downloading a Trojan horse program. Could be in a document, could be in a link. It could also be because they're unpatched, or that their password has either been previously stolen and known, or that the hacker can guess at it. But either way, this initial stager Trojan horse program gets installed on the first device. That Trojan horse program usually modifies the computer so it can live through a reboot. It then collects all the passwords. Typically, it collects all the passwords it can see, especially any of the ones you've been saving in your browser, and then uploads everything to the command and control server, including the information, the victim's IP address, network name, and host name, enough information that the hacker, seeing that information, kind of gets an idea of what type of computer they've broken into, what organization it belongs to. The malware program stager will typically look for instructions to see if the hacker has left any instructions that should follow. They'll usually download at least 2 other malware programs and install them in different places. They're all completely independent of each other, and they're completely different types of programs, so that if your antivirus program detects 1 or 2 of them, the other one will live. Most of them are undetectable by antivirus, and that's because the developers follow the antivirus companies and will tell their malware programs to re-encrypt themselves anytime they start to be noticed by some of the scanners. So typically, they'll the malware programs will actually dwell in these computers and networks for many weeks or months. The average dwell time used to be 8 to 12 months. When I made the slide, it's closer to 3 to 4 to 5 to 6 weeks of dwell time. But that means that these malware programs, ransomware programs, password stealing Trojans are lurking, dwelling for many weeks without being detected. I've even seen companies that have been compromised for years. I even know of multiple companies that the malware program is on the system so long that they thought it was legitimate software, and they started to ask their system integrator, like Dell SecureWorks, to actually put it in as part of their build image. So they're in there. Eventually, the hacker will check into the command and control servers, get a list of everything the malware is broken into, and then they'll decide to log into the victim. Typically, the first time they log on in, they're using a remote backdoor of that Trojan program, the initial Trojan program. But after that, they'll figure out, how does the real administrators administrate this network, and how do the users log into the computers? Is it, Microsoft Remote Desktop Protocol? Is it VNC? Is it Log Me In? What is it? And they'll start to use that method only, because it's really tough for any of the defensive intrusion detection tools to know the difference between a bad guy using RDP and a regular good admin using RDP. Typically, they're only going to use scripts from that point, using programs and utilities of Windows computers to do all of their surveying and analyzing and collecting passwords and hashes and that sort of stuff. And that's because they don't want to upload a whole lot of other malware, because each additional malware program could be something that's detected. Instead, they're using scripts and living off the land, using the utilities of the systems that they've broken into. They'll look around, they'll eavesdrop on emails, they'll download financial statements, they will steal whatever they want. That they think might be of value, of something that they could use to get money, or maybe tell the company, if you don't pay us the ransom, we're going to release your information to the internet. That's really, really common today. They'll steal whatever they want. If they're ransomware, they'll eventually kick off some ransomware program that encrypts a bunch of computers and ask for the ransom. This is how most malware works today. This is how most hacking happens today. And some people will go, well, why didn't they? I found malware. Why didn't they hack me? It's because they have a million other people that it literally takes them time to go through their list and decide who they're going to hit when. But it's out there, and a lot of people, there are tens of millions, if not 100 million computers and programs that are compromised that don't know that they have some malware just waiting for the hacker to log on in there. Why is it important to fight phishing? Well, if you want to stop from being hacked by hackers and malware, you got to figure out how they're breaking in. If someone's, if you got ninjas breaking into your house, you got to think, well, and if they're breaking into your house over and over, you got to say, are they coming through the windows, the doors, the floors, the ceilings, the wall? If you want to stop ninjas from breaking into your house, you got to figure out how they're breaking into your house and then mitigate how they could break in your house to stop them. That's the same thing with computers, is that if we want to stop hackers and malware, we got to figure out how they're breaking into our computers and networks. And there's a lot of different ways they could do it. Last year, there was over 20,100 different software firmware vulnerabilities alone that we were told that we had to patch if we want to keep hackers and malware out. And that's on top of hundreds of millions of malware programs and all types of human-based adversary attackers, like I just covered, financially motivated, nation states, spies, and all that sort of stuff. There's a lot of ways that you could be attacked. But, and this is important, pay attention here if you're falling asleep, out of all the ways that you could be broken into, these are the 13 categories. Every single hacker or malware attack that has ever occurred since the beginning of the computers falls into one of these categories. And, and if you want to stop hackers from breaking into your house or your devices or your company, you need to figure out which of the most likely ways that hackers could use to break into your device or network, and then try to mitigate those problems. Well, if you didn't know this, since the beginning of the computers, two reasons have been the top two reasons why people are broken into. 70 to 90% of all hacking involves social engineering. So if you got rid of that one problem, you get rid of 70 to 90% of your risk. Unpatched software is involved in about 20 to 40% of all successful data breaches. And those two things alone account for 90 to 99% of the risk in most organizations. There's a third risk that changes over time. But these days it's passwords. They've either stolen your password, usually through social engineering or unpatched software, or they're guessing at your password because it's weak. If you put those three things together, social engineering, unpatched software, and password threats, it is 99% of the risk in most organizations. All the other ways that you could be compromised, which you could be compromised through misconfiguration or trusted insider or whatever, could happen. But they're all together, they're less than 1% of the risk. So what this means is that if you want to stop hackers, you really do need to concentrate, however you do it, on stopping social engineering, making sure you patch your software, and then password issues. And that's what I'll cover today. I think all of us have seen a lot of phishing, right? That's where, you get this email and it's claimed to be from some trusted vendor, but it's a scam and they want you to click on some link, some rogue URL link that doesn't take you to where you thought you were going. Like the first one looks like PayPal, and you have a hard time seeing the link here, but it actually says epaypal.com. Well, epaypal.com is not PayPal, but this other one's supposed to look like Microsoft, but it really came from outlook.com, which is just a general email address. And actually, but they're trying to get you to click on an address or call a phone number to reveal your logon information, and then they would use that to try to rob you blind. Sometimes you'll get these connections over social media. I think we've all had friends that were compromised on social media and we got some weird message going, I need money, or look at this funny video. And I love some of these, like this one that says it's from Facebook. So like, click here to update your Facebook account. Facebook never asks us to update software. It's cloud software and they update it on their own. Or the one behind that looks like Twitter, like, oh, verify your Twitter account. If it really was Twitter, it would say twitter.com, not 00webhost.app.com. Or the one that says, oh, this is from LinkedIn, your account is suspended. Well, LinkedIn, if it really was from LinkedIn, that link would say linkedin.com. Instead, this is LLlinked.ni. NI is the country code for Nigeria. I worked for Microsoft for 11 years. I can assure you they have no LinkedIn offices in Nigeria. So it's just a scam. And again, maybe people will break in on social media accounts from our friends and go, I just got one of these the other day. I can't believe this video that you were in, and the idea is like, oh, what video am I in? And you click on it. Well, a lot of times these are scams, and especially if they ask you to try to install software to watch the video, like you need to install this browser extension, or you need to install Adobe Acrobat or something. If you're ever asked to install something to watch a video, don't do it. It's probably a scam. We also see a lot of these fake invoice scams. We call them business email compromises. They're the number 2 most damaging scam after ransomware. But like, here's an example. Well, I was the InfoWorld weekly security columnist for 15 years, and I got this email claiming to be an invoice from Maersk. They're the largest shipping and container company in the world. And, I was just a writer, so I don't pay invoices. So I knew this was fake. But somebody might be tricked into thinking, oh yeah, I paid these invoices. And let me say again, these fake invoices are the #2 most damaging problem in the world today after ransomware. But so people end up paying these invoices, or in this case, they wanted me to download the invoice example and had malware attached to it. But I knew it wasn't Maersk because the URL there is not Maersk.com as it would be if it was from Maersk, but it's onlinealex.com.pl from Poland or something. That's what, I don't know whose address it is, but it's not Maersk.com. We're seeing a lot of SMS phishing messages, which we call smishing. These are all real phishing messages I've gotten. The one in the upper right there says account locked, Wells Fargo customer service, and it has a short messaging link, so you don't know where it's going to go. Well, I'm not a Wells Fargo customer, so I knew it was a phishing attack, but Wells Fargo has like 20 million customers, and I'm sure some of the people that got that phishing attack, clicked on it and got taken to a fake Wells Fargo page and put in their login name and password and got robbed. On the bottom right there is actually a smishing message that my friend Stephanie sent me. It was one of those, hey, it's FedExpress or DHL or Amazon. We tried to deliver a package, but you weren't home. And they want you to click on that and provide your, Amazon information, and then they rob you blind. But she was like, Roger, I think this is a scam, but it has my name in it. How do they have my name? And I'm like, well, you just look that up on the internet, but you can imagine that these phishers were putting in people's names, taking the time to get the phone number matched with the first name, because more people are more likely to open that message just because it seems like, oh, well, this person must really know who I am. Nope, it was a scam. You can, of course, be directly targeted by a human adversary. And let me say that for 20 years, I was a professional penetration tester, a hacker that was hired to break into places. I broke into every place, and this is hundreds of places that I was hired to break into in an hour or less, except for one place that took me over 3 hours because it was the second time I was there. But, so I broke into everywhere. I broke into every website and device and multi-factor authentication device someone sent me. They said, Roger, go hack it. I hacked it. And I'm not some world-class hacker. On a scale of 1 to 10, I'm maybe a 5 or a 6. I'm very average in hacking. But the way that you hack is this method right here. It just isn't that hard. It's like being a plumber or an electrician. Once you know the method and you've kind of been experienced with some of the tools, it isn't that hard. Same thing with being a human hacker. The easiest way to break in is just being a social engineer, but assuming that you're going to not socially engineer it, the next best way is to try to exploit unpatched software. So unpatched software is involved in 20 to 40% of successful attacks. And the way that a human adversary would do that is they need to have a scanning tool that they run against the targeted victim. So they're going to run the scanning tool against KnowBe4.com, or maybe they've gotten an email from me. And if you're smart, you can actually look into emails and find the IP address of where it came from. And then, or even messages that I might chat to you could leak my IP address. And then you can scan them, and the tool will tell you what type of operating system they're running, what type of software, and what versions. And it's important to know the versions, because the version numbers will tell you whether or not that thing is patched. And in my 20-year career breaking into places, I never found a single computer device that was fully patched. And then you go to a website, and there's literally dozens to hundreds of websites that have exploits that allow you to break into places. So the most common scanning tool, and there's hundreds of these tools out there, but the most common one that's been around since 1997 is called Network Mapper, or Nmap. But you just type in like Nmap, KnowBe4.com, and it will run the scan and tell you what open ports it finds, whether it finds a firewall or not, what software is running. Again, really importantly, what version numbers. It's like if I was to see Apache, that's a web server 2.2.2, I go, oh, that's a vulnerable piece of software, and I can go look up the exploit for it. It's also telling me this particular target's running Linux 2.6. This is an old picture from a long time ago, but even back in 2007 when this picture was taken, that was old buggy stuff. Then all you have to do is go find a website that has exploits against that unpatched software. And there, again, are dozens to hundreds of them out there. The most common one out there, the most biggest, longest lasting database I know is exploit-db.com. It has over 44,000 exploits. You need to break into a Windows machine, here you go. You need to break into a Mac machine, here you go. You need to break into a Linux machine, here you go. You need to break into an Oracle database, here you go. You need to break into an Apache web server, here you go. And you literally download, you may have to compile it or run it through a Python script or something like that, but literally it's that easy. I run a scanning tool. I find out what software they're running. I find out what version number they're running. And suppose the victim's fully patched. Well, I can just wait until the vendor, I now have a list of all their software, and I'll just wait till the vendor announces a new exploit. It's Patch Tuesday yesterday. Microsoft's announced a bunch of exploits. All I got to do is beat the victim to patching. And there you go. You'll hear a lot of people say, well, multi-factor authentication will save me. Let me see if I got an example. Here we go. Multi-factor authentication, it could come through your cell phone, like you had a code here. Maybe it's like a USB key, or maybe, it's like you're doing a fingerprint swipe or something like that. Multi-factor authentication is a good thing, and you should have it, but it is very hackable. I wrote a book called Hacking Multi-Factor Authentication, and I frequently show people this demo that I'm going to show you in a minute about how easy it is to bypass most multi-factor authentication. And you can stop being hacked by doing one thing, which I'll share in a minute. But just know, multi-factor authentication is a good thing. It is not the savior panacea that so much of the world is painting it to be. It is trivial to get around most of it. And I'm going to tell you how you can make it so it's not so trivial. But the way that a really common type of attack happens, this works against 95% of today's multi-factor authentication, is an attack called network session hijacking. It also, you could call it a man-in-the-middle attack. Microsoft calls it the adversary in the middle. But how the attack begins is that a hacker creates a phishing email that looks like a trusted brand that the victim would trust, Microsoft, Instagram, Twitter, whatever type of credential they're trying to get or website they're trying to get on. They send that phishing email with this rogue URL in it to the victim. And if the victim looked and hovered over that URL before they clicked on it, they would notice that it's not the right URL. It's some gobbledygook. It's not Microsoft. It's not Instagram. It's not Twitter. It's not Facebook. It's some gobbledygook rogue URL. But if they don't notice that because the email looks official to them and they get tricked, that link will take them to what's called a man-in-the-middle rogue transparent proxy website, which is just the hacker's website. Then that will take anything that the victim types in and send to the real victim's website that the victim thought they were going to in the first place. And it takes everything the victim's website and sends it back to the victim so that the victim is seeing everything that looks the same, because it really is coming from the real website, except for there's a man-in-the-middle attack in the middle, and vice versa. The real website doesn't know that the IP address that's connecting to them isn't the victim. They don't know the difference in most cases. But the hacker, because they have this man-in-the-middle website, can now capture everything the victim types into the web server. So login name, password, multi-factor authentication code, and then everything the victim's website could send back to the victim, credit card information or anything. Really what they're looking for is this thing called a network access control token cookie. After you log into a website, whether you're using MFA or not, that website will always send a text-based cookie, they call it, back to your browser. And all that's in there is kind of some gobbledygook, hexadecimal letters and numbers. It's called a session ID. It just kind of stands for you. It's a bunch of letters and numbers that stand for you during that session. And then as you go on that website, that session cookie is like your driver's license. It says, oh, you've logged in successfully. You're allowed to go here, here, and here. Well, because the hacker has the man-in-the-middle website there, they can capture that access control token cookie, disconnect the victim's login, and then log in as the victim. This is a really, really common type of attack. I first wrote about it in 1989. It has been done tens of millions of times. It is the most common way to get around multi-factor authentication. And I'm going to show you a demo of this. Actually, Kevin Mitnick, KnowBe4's chief hacking officer, used to be a world famous hacker years ago. But he's got like a 6-minute demo. If you want to see everything, I'm going to show you a 2-minute version. It's me narrating, but I just want you to see how easy it is to pull off. So stand by, listen, and watch this attack. I think it's me narrating it.
So here we are on an inbox, a regular looking inbox, and one of those emails has a phishing email. Kevin's going to click on it. It looks like just a normal email from somebody saying, hey, let's connect on LinkedIn. But this is a phishing email, and if the victim was looking at the URL, they'd see that it's llinked.com, not LinkedIn. But a lot of people would miss that, think it was from LinkedIn, and then clicked on the button. When they clicked on the button, if they didn't realize it was taken to the wrong place, if you look up in the top hand side there, it's LL LinkedIn, not LinkedIn. But really what this is a man-in-the-middle website that's capturing when the victim types in their login name and password. And even LinkedIn is going to prompt the victim to input their MFA credentials after they put in their login name and password. But really what the victim is connected to is a man-in-the-middle website that is capturing all that information, the login name, the password, and the multi-factor authentication code that they type on in here. So the person gets sent the code, they type it in, they think they're putting it to the real website, but really it's a fake website that's capturing it. If you look behind the scenes there, the hacker, using their hacking tool behind the scenes, has captured the login name and password. The victim is actually in on the real website right now. It has passed them through to the real website. But this is what the hacker captures. You can see email address, password, and what's called the access control token cookie. They could have, if they wanted to, captured that 4 or 6 digit code that they typed on in, but they really, in this particular case, don't even need it because they have the website's cookie. Every time someone logs in successfully, whether it includes MFA or not, the website will send back a cookie that basically says, hey, you've been approved, you authenticated. The hacker can capture that and then paste it into their browser. So here is an example. Kevin is going into his browser, going to the LinkedIn real website. He's not even going to try to log in as the user with their login name and password. He's simply going to inject the stolen cookie into his browser session. He's doing it right here. He's going to open up the admin console, the developer console, copy that stolen cookie into his browser, and simply refresh his browser, and he will be logged in as the victim. And there is the attacker on the real website and as the victim. And this sort of attack would work against probably 90-95% of multi-factor authentication today.
And how could you prevent it? Simply by hovering over the link and realizing it's not taking you to the right place. That's how it's really simple to defeat. But a lot of people think, oh, if I have MFA, I don't have to pay attention as much because MFA protects me. It doesn't in most cases. If you're interested, the hacking tool Kevin used, it's called Evil Jinx, it's been around for 10, 15 years, but there literally are dozens, if not 100 hacking tools out there that do the same thing. And really to hack you, especially through SMS, I really don't even have to be, if you have SMS-based MFA, I don't even have to be an Uber hacker. I can just, when I have SMS, I can pretend if you have an account that can be recovered through SMS. Most of the big login accounts, Microsoft 365 and Gmail and your stock account, your bank account, they allow you to recover those accounts using SMS. They'll send you a code in SMS. I can literally just pretend to be from that vendor. Like if I know you have a Gmail account, I can say, oh, I'm from Google Security. We've detected a rogue sign-in to your Gmail account. In order to determine a legitimate login, we're going to send a verification code to your previously registered phone number from another Google support number. Please retype the sent verification code in response to this message, or your account will be permanently locked. And then the hacker just goes to Gmail, puts in your email address, tells Google Gmail they forgot your password. Google will put that account in account recovery mode, say, which way do you want to recover it? They give them 5 different ways. They pick send a code to my phone. Victim gets that code sent to them. And if they give it back to the attacker, it's game over. And let me say, it can be done a bunch of different ways. Like I could say, hey, Roger, this is from the county. We've detected a large water main break that's been detected near your primary place of residence. Do not drink the water, from the tap until further notice. We apologize for the inconvenience. Do you wish to be enrolled for proactive status updates about this event? Reply yes or no. And as soon as they reply yes, you got them, because who doesn't want to know that they can drink the water again and take a shower and stuff. And then the attacker can say, well, thank you. Please reply with the confirmation code we sent to confirm your phone number, which is ironic because they are already texting you. They know your phone number. But what you don't know is they've gone into your stock account, your bank account or whatever, said, put it in account recovery mode, send me a code. You get sent the code. If you send that back to the attacker, they're like, thank you so much. You're now protected by the emergency warning system. But what you don't know is they've now taken over your bank account, your stock account, and it's game over. And literally, there's just all kinds of scams that can be done to get these codes from you. So just know that SMS, if someone claims to be somebody in SMS or calls you, you don't really know who they are. So all these different ways you can be hacked, what can you do? If you're falling asleep, pay attention here. Here are the 4 or 5 best ways that you can prevent yourself from being hacked. Number one, anything you can do to stop from being tricked by social engineering, whether it's educating yourself, changing organizational policies, or implementing technical defenses, everything you can do to stop phishing is going to help you. Phishing is involved, social engineering phishing is involved in 70 to 90% of all attacks. If you can stop phishing, you're getting rid of most of the problem. Make sure to patch your software. 20 to 40% of attacks involve unpatched software. Remember I said there's 20,100 vulnerabilities announced last year? Only 2 to 4% of those are ever used by any real-world attacker against any real-world target. So really, you only have to patch the stuff that attackers use. And you're like, well, what did the attackers use? CISA, the Cybersecurity Infrastructure Security Agency, has a list called the Known Exploited Vulnerability Catalog. You can subscribe to that. And every week or every day, they're going to send you a list and go, oh, this is software that whenever they detect a hacker, any hacker in the world using software to attack any real world target in the world, they'll tell you what that is. And if you have the software or the firmware or the device that's on that list, get it patched ASAP because it's being exploited in the wild. And I know I said I could hack MFA, and that's true, but you should use phishing resistant multi-factor authentication where you can protect valuable data and systems, because about half of social engineering involves stealing your password. And if you're using MFA, they can't steal your password. But you should use non-phishable MFA. What does non-phishable mean? One that cannot be man in the middle of the attack, like that demo I showed you. And if you don't know, like Roger, I don't know which ones are or aren't. I have a list called My List of Good Strong MFA, where I tell you exactly what MFA is not easily phishable, like anything that's FIDO, F-I-D-O. That's one of my favorites. FIDO MFA is not easily phishable. You're still going to have to use passwords. If you create passwords out of your head, they're going to have to be 20 characters long if you want to stop all hackers. I know hackers that successfully guess at 18-character passwords that come out of your head every day. Like literally, hackers can guess up to 20-character passwords now, no problem. If you want it to be unguessable or uncrackable by a hacker, you need a 20-character password if it comes out of your head. If you get a password generator or a password manager, your passwords only need to be 12 characters or longer and fully random. Most people don't like using or creating fully random passwords or long passwords, so I'd recommend that you use a password manager instead. Password managers will create fully random complex passwords that are different for every website and service, and you don't need to remember them because you're just clicking on sites inside the password manager. And then teach yourself and everybody you know and love and all your coworkers how to spot rogue URLs. Rogue URLs are involved in most phishing attacks, and if you know the difference between a good URL and a rogue URL, you're much further along. And I have 2 links there. The first one just goes to an article called The 12 Most Common Rogue URL Tricks. The second one is a 1-hour webinar where I go over 55 different examples of rogue URLs. Everything you do to prevent phishing, if this is really meant for organizations versus a person, but if you're interested in everything I could think of to help you stop phishing, there you go. There's a 1-hour webinar I give. I think it's got 99 slides. The second one's an ebook there. It's 46 pages, and they both cover the same things. Just everything I could think of to every policy, technical defense, and best practice education thing you should do to stop phishing. Really educationally wise, you want to teach yourself and your coworkers how to spot phishing, how to spot bad things, and then how to respond, which is at home to delete them, at work to report them to somebody. And this is what I would say, that if you want to stop being socially engineered, this is really what you need to do here, is teach yourself and your family and your mom and dad and whoever else how to spot a phishing message. This is the 2 most common traits of most social engineering and phishing. First of all, the message arrives unexpectedly. It could come to you in email, could come from a website, could come in a text message, could come in social media, could come in a phone call, could come from someone knocking on your front door. But either way, this message, this action arrives unexpectedly. You were not expecting it. Then the requester is asking you to do something that you've never done before for that sender. So even if you think you know them, if you think it's coming from a coworker or a friend or a boss or Bill Gates or whatever, they're asking you to do something you've never done before that person. Any message that has those 2 traits, you weren't expecting it, it arrived unexpectedly, it's asking you to do something new for the first time for that person, don't do it right away. It has a much higher chance of being a social engineering attack, and you need to research that request. Call the person on a known good phone number, go directly to the website, don't click on the link, but you need to research it before you do that action. If you train yourself to be this way on every single message you receive, you're going to be far less likely to be socially engineered or hacked, and that gets rid of 70 to 90% of the problem. If you want to see the 22 red flags of social engineering, the signs that anybody should see in a phishing email to know it's a phish, we got a PDF. You can download it from that link there, and you can print it up and you can send it to other people. I even have what's called the 12 red flags of rogue URLs. And that just tells you the 12 most common tricks that hackers and phishers use to try to trick you into clicking on rogue links. And you go to the link at the bottom, and you can download that, print that, send that to anybody. I'm also going to send that to the host of this webinar to make sure that they have a copy of it. Or you can email me, rogerg@knowbe4.com, and I'll send it to you. But to finish up, I do think that, what should your password policy be? Well, use phishing resistant multi-factor authentication where you can. If you can't do that, I would then suggest you use a password manager for where you really need to use passwords, because they can create 12 character or longer perfectly random passwords that are unguessable, uncrackable. If you have to make passwords out of your own head and you really want them to be the most secure, they need to be 20 characters or longer. Because again, I know people that are cracking 18 routinely every day, cracking 18 character passwords. And they all agree that if you have a 20 character password, they can't guess it or crack it. So that's my policy. I work for KnowBe4. We're very big believers in training people and teaching them about hacking and social engineering. Our average customer that comes to us, about 30% of their employees can be socially engineered and phished. After they get educated and we do some simulated phishing tests against them at least once a month, it gets below 5% or below 5%. And that's not our best customers, that's our average customer. And because social engineering is involved in most hacking, that's an important thing to do to teach people not to be as phishable. In the past, I'm going to take some questions. If we don't get to your questions today, or you just don't want to ask them in public, you can send them to me at rogerg@knowbe4.com. You can also follow me on LinkedIn and Twitter. But with that, I'm going to ask Phil or anybody else, and I'll try to look at some questions here. Did anybody come up with any questions like, Roger, were you taking amphetamines to talk this fast? The answer is no.
Yeah, Roger, thank you so much for all of the resources you shared and all of the great information. There is a couple questions here. First one up, between the two options, are non-guessable passwords / zero trust or passwordless / zero trust options the better way to go?
That's a good question. Zero trust isn't all the way here. You can buy zero trust in different components. So we don't, zero trust is the holy grail to get to, that we all need to get to. Probably one day, we're talking 10, 20 years, it's probably going to be more of your behavior. Like when you use your credit card, your credit card works most of the time, but sometimes like, oh, you're buying a TV and you're in a strange city, in a strange store, we're going to call and authenticate you before you can use it. That's probably what it's going to be like. I am a big believer in multi-factor authentication. A lot of passwordless authentication is single factor. And I'm more of a multi-factor person. With that said, I also think passwords are going to be with us for at least another decade, if not decades. So I think we're all going to have a bit. I think we all have a bit of, I think we're all using passwords, and all of us are using multiple types of multi-factor authentication already. I think that's going to continue for another decade or two, no matter what I say here. But I think eventually we're going to get to this thing to where it will look at us and what we're doing and know where we're coming from. Are we coming from a trusted device? And we're going to get to that eventual zero trust. Anything you can do to get to zero trust in a good way is a good thing to do.
That's great advice. No lie, Roger, during this webinar, I actually got a phishing text message. So that's a little bit of irony to throw into the middle of it. We've got some great feedback from the community saying thanks and appreciating your verbal speed. So when you're working with organizations and testing them using your tools, what's the efficacy? What are you seeing? How often are people clicking on your test emails for phishing with your education services?
Yeah. So again, when they're brand new, routinely we see around at least a third to 40% of people. And it's funny, when we do what's called a baseline phishing test, the sysadmin that's involved us, they're like, oh, we do this really basic fish, typos, and it doesn't seem to have anything to do with the company. They're like, no one's going to click on that. Hardly anybody's going to click on that. And then they're shocked. And they're the ones that kind of hired us because they knew it was a problem, but they're still shocked that 30% of their employees opened it up. But then we say, you do every year when you hire somebody, or at least every year thereafter, you do this longer training, computer security training, maybe 30 minutes, 45 minutes an hour. And then every month it's a shorter training about the latest problems like COVID phishing emails, or maybe it'd be election phishing emails this week, or maybe in February or April, it's tax phishing emails asking for your W-2 information. But you give these smaller education and you do at least monthly simulated phishing. And we know that customers that do that get to 5% or below.
Oh, that's fantastic percentages. I've worked for organizations where it's been an annual thing as a compliancy type checkbox. It just doesn't sound like that's sufficient anymore.
Yeah, we're getting ready to release a report that shows that doing education or simulated phishing once a year has the same impact as not doing it at all. Wow. We don't see any significant benefit till it's done at least once a quarter, and once a month seems to be kind of the sweet spot. But the whole compliance thing once a year, it really is pretty worthless. And I'm getting ready to release a report and send it out to my friends at CISA because they recommend once a year. I'm going to say, listen, it's really not doing people enough. Once a year, what happens is people it's not reinforced. They forget. You got to do more frequent stuff.
You got to have practice. We got a question from Eric also. Who would you recommend? I guess maybe what's your top 2 MFA services you would recommend?
I'd say go to that link list that I have there because it lists all the ones that I know are there. I'm a big fan of FIDO, anything that's FIDO, because it disables those man-in-the-middle attacks. But there's a lot of other really good options out there. Beyond Identity, Hyper, probably a couple handfuls of vendors that I like. But you know what they all have in common? They're not easily phishable. That's what I'm looking for. Although I'm getting ready today, as soon as I hang up with this, I'm doing a new biometric webinar where I say a lot of people love biometrics and all this stuff. It's just as hackable as anything else, not nearly as accurate as you think, but it's all right. It's all right like the other solutions. But even if you use biometrics, I'd say try to make sure it's not easily phishable. And biometrics a little bit less phishable because most of the time you're doing your biometric into your device. But we're seeing an increased use in biometrics for remote logins to applications, and that has us concerned because it can most cases can be easily phished around. And if that's the case, I'd rather use something that's phishing resistant.
Yeah, absolutely. So I want to say thank you, Roger. I don't see any other questions, but if there are more questions for Roger, here's his email address right on the screen. Please do reach out. I'm going to switch back for just a quick minute and just remind you that we've got a couple of things going on from a XenTegra perspective. Remind you again about the, well, let's see. Fumbling. We've done questions. We've got a few webinars coming up in the weeks to come. So we've got one from several other partners. We've also got some workshops and boot camps if you're interested. Those dates are available on the screen. We've got some things from Nutanix coming up both in November and in December. And as we said at the beginning of the presentation, keep a watch on your email. We will be sending out a notification to the lucky winner of a $100 Amazon gift card for your attendance today on this webinar. And on behalf of XenTegra and KnowBe4, I want to thank you guys for all showing up and for listening to the great advice that Roger's got for us. So with that, Roger, thank you, my friend, and we will see you again soon.
Thanks, everyone. Take care. Continue to fight the good fight.
Have a great afternoon.